Achievers Paradise CMC PU College, number 1 PU College in CHITRADURGA. For admissions, contact 9008080 and 9606380135.
Very good morning, my dear students. Myself Jayakumara K, lecturer in mathematics, CHITRADURGA College, CHITRADURGA. In this class, I am going to discuss about the very important topic in second PUC, that is the fifth chapter, continuity and differentiability. Dear students, the weightage of this chapter is 20 marks. Among that, you will get 1 mark 1 question, 2 mark 2 questions, and 3 mark 2 questions, and 5 mark 1 question and 4 mark 1 question. That is totally you will get 20 marks to this chapter. Right. Now, first we will discuss about the concept continuity. Right. Here, continuity. What do you mean by continuity? Generally, what do you mean by continuity? Continuity means continuous. Continuity means continuous. The word continuous implies what? Without any break. Right? Without any break. That means a chain without any break, or a cube without any gap. Okay, like that. Here, now, here observe. Here, this is a line without any break, right? This is a line without any break. Then this line is what? Continuous. Then this line is continuous. If this line has any breaks, or any holes, here this function contains, this line contains. Here, this is a break and this is a hole. Then that function is what? Then this line is what? This is not a continuous. Okay, right. In general, in mathematics, what do you mean by continuous? Here, if we draw a graph of a function, for example, if we draw a graph of a function without any break, then the graph of that function is said to be continuous. Okay, now, if we draw a graph of a function without any break, then the graph of that function is said to be continuous. Okay, if we draw a graph of a function without lifting the pen, one pen ettadale ಒಂದು function ನ graph ನಾವು draw ಮಾಡಿದ್ರೆ, then that graph of that function is said to be what? Continuous. Okay, right. Here also, continuity of a function is defined at some particular point. Continuity na ನಾವು ಡಿಫೈನ್ ಮಾಡೋದು ಯಾವಾಗಲೂ ಕೂಡ ಚೆಕ್ ಮಾಡೋದು continuity ನ ಒಂದು ಸಮ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ಓಕೆನಾ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಒಂದು ಫಂಕ್ಷನ್ ಇದೆ ಅಂದ್ರೆ, ಓಕೆನಾ? ಹಿಯರ್ ದಿಸ್ ಇಸ್ ಎ ಫಂಕ್ಷನ್ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಫಂಕ್ಷನ್ ಈ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ x 2 ನಲ್ಲಿ x 1 x 2 x 3 ಈ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿರುತ್ತಾ ಇಲ್ಲ ಅಂತ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಹಿಯರ್ x 2 is a particular point. Here we have to check whether this function is continuous or not at this particular point. Okay, now if this function does not have any break, then the function is said to be what? Continuous. Okay, right. Now continuity at a point. Definition: a function f of x is said to be continuous at x is equal to a. Here that point is here a, x is equal to a. If the graph of if we draw a graph of a function without any break or hole or gap at that particular point, x is equal to a. Okay, now if we draw a graph of a function, without any break or hole or gap at that particular point, then that graph of that function is said to be what? Continuity of the function at that particular point. For example, here graph of the function here is, here this is a function f of x is equal to x square. Here observe, this particular point is a. Here I am taking this particular point here is a. Here we have to check this function is continuous or not at this particular point. Here observe, this function is continuous at this point. X is equal to a. Okay, here observe, here the graph of the function at x is equal to a. Here we are moving from left to right. Here we will get a hole or break. Then this graph of the function is said to be what? Not continuous at x is equal to a. Okay, now this function is not continuous at x is equal to a. X is equal to a ನಲ್ಲಿ ಈ ಫಂಕ್ಷನ್ ಏನಾಗಿಲ್ಲ, ಕಂಟಿನ್ಯೂಸ್ ಆಗಿಲ್ಲ. ಓಕೆ ನಾ, ರೈಟ್. ಬಟ್ ದಿಸ್ ಫಂಕ್ಷನ್ ಇಸ್ ವಾಟ್? ದಿಸ್ ಈಸ್ ಕಂಟಿನ್ಯೂಸ್, ದಿಸ್ ಈಸ್ ನಾಟ್ ಕಂಟಿನ್ಯೂಸ್. At which point? At x is equal to a. Right. Now here there is one more very important important definition for continuity. That is, on this definition we are going to solve lot of problems in exercise 5.1. Right? Observe definition here. A function f of x is said to be continuous at x is equal to a. At x is equal to a, if the following three conditions are satisfied. Here there are three conditions for continuity. Here the first condition is f of x is defined. F of x is defined. That means f of a is defined. Okay na? F of x is defined is f of a is defined. That means next second condition, limit of f of x as extends to a exists. That means limit of a function exists at x is equal to a. Okay na? By the definition of limit of a function, limit of a function exists at x is equal to a, and that limit should be what? Finite. Limit of a function exists and is finite. And the third condition is limit of f of x as extends to a is equal to f of a. That means the first two conditions are what? Equal. These two conditions are what? Equal. Here first condition, second condition. Here these two conditions are equal. Then the graph of that function is said to be what? Continuous. At which point? At some particular point a. ಯಾವ ಪಾಯಿಂಟ್ ನ ತಗೊಂಡಿರ್ತೀವಿ ಅದಾಗಿದೆ. ಓಕೆನಾ? Here at x is equal to a ನಲ್ಲಿ function continuous ಆಗಿರಬೇಕಂದ್ರೆ here there are three conditions. That is, first condition is f of x is defined. F of x is defined. Second condition, limit of a function exists and is finite. And third condition is limit of f of x as extends to a is equal to f of a. That is, first two conditions are equal. Okay. Here, for example, here discuss the continuity of a function f of x is equal to 5x square. For example, our function is f of x is equal to 5x square at some particular point x is equal to 1. At some particular point x is equal to 1. Here x is equal to a. Here a value is equal to what? X is equal to 1. That is, x is equal to a is equal to 1. Okay. Here we have to check whether this function is continuous or not. At this point x is equal to 1. Okay. Here first definition. Here first condition of this continuity is what? F of x is defined. That means f of x is defined at what? X is equal to a. Here f of x is defined at what? X is equal to 1. Okay, we have to check at x is equal to 1. At x is equal to 1. Here f of x is defined as what? At x is equal to a means f of a is defined. That means at x is equal to 1, f of 1 is equal to what? 5 into 5 into x square here is 1 square. That is equal to 5 into 1 is equal to 5. Okay. And the second condition is limit of a function exists. Limit of a function exists at x as x tends to what? A. Here observe limit of a function. Here second condition is the limit of f of x as x tends to a. Here x tends to a. Here a value is equal to what? A is equal to 1. That is equal to limit of f of x as x tends to 1. Here what is the value of the function? What is the value of the function? That is equal to f of x value ಏನಾಗುತ್ತೆ? Here that is equal to limit as x tends to 1. Limit as x tends to 1. F of x value, f of x here is equal to what? 5x square. 5x square. As x tends to 1, this becomes what? 5 into 1 square. That is equal to 5. 5 into 1 square is equal to 5. Here observe first condition, f of 1 is defined, f of a is defined, f of a. Second condition, limit of a function exists. Limit of a function here that is exists and that value is equal to what? Finite value 5. Okay na? Here also these two conditions are what? This is also 5, this is also 5. That means these two conditions are equal. That means first two conditions are equal. That means limit of a function exists at x is equal to what? 1. And limiting value is equal to what? 5. That means therefore we will write limit of f of x as x tends to 1 is equal to f of 1 value is equal to both the values is equal to 5. That means limit of a function exists at x is equal to 1 and that is equal to 5. Okay, right. Observe from these three definitions. From this definition, here the first condition implies what? F of x is defined at x is equal to a. And the function exists and is finite. That means what? That means limits. Limits means here observe, come to the topic, first PUC topic. This is limit of a function. What is the definition of limit of a function? Here observe, limit of a function means a function f of x is said to tend to limit L as x tends to a, or x get approaches to a, or x gets closer and closer to a. If limit of f of x as x tends to a is equal to what? L. That's equal to f of a. That's equal to y. How means here observe. For example, here I am considering a function f of x is equal to x square. F of x is equal to x square. Observe. Here, as x tends to a, this is some point x is equal to a. X is equal to a. X tends to a means here observe, x tends to a is denoted by x tends to a. X aroma a. Okay. Here x tends to a means x gets closer and closer to a. Here this is a value. Okay. This is a. This is x value. X gets closer and closer to a. Okay. From the left side of a. Okay. Here x gets closer and closer to a from this side. Okay. From upper side. That is from right side of a. Here limit of a function means a function f of x is said to tend to limit L. Limit L means here this is a means this particular point is f of a. This particular point is f of a. Here this is b means this is f of b. Okay. Here a function f of x is said to tend to limit L as x tends to a if limit of f of x as x tends to a is equal to L. L is nothing but what? Limiting value of the function. F of a is nothing but limiting value. F of a here is nothing but what? That is nothing but y value, right? That means limit of a function is nothing but the value of y. The value of y at some particular point. Value of y at some particular point. Here, once again, limit of a function. A function f of x is said to tend to limit L as x tends to a. If limit of f of x as x tends to a is equal to L, that's equal to what? Value of the function f of a. F of a here is nothing but what? The value of y. Okay, right. Now, limit of a function means the value of y at some particular point. Now, here there are two types of limit of a function. First one is left hand limit, LHL, and that is denoted by LHL. Left hand limit means the value of the function. For example, this is the graph. This is the graph of the function. Okay, here observe the value of the function from the left side of a. Okay, here this is x is equal to a means the value of the function from the left side of a. X approaches to a from the left side of a is called what? Left hand limit. Okay, the value of the function from the left side of a, is called what? Left hand limit, and that is denoted by left hand limit is denoted by LHL is equal to limit of f of x as x tends to left hand limit a minus. Okay, and that is equal to limit as x tends to 0. Here we are changing the limit. H tends to 0. Here it is what? X tends to a minus. This becomes h tends to 0. Function gets treated as f of a minus h. Okay, left hand limit LHL is equal to limit of f of x as x tends to a minus. That is equal to limit as x tends to 0 f of a minus h. Okay, next. Similarly, right hand limit. Right hand limit means the value of the function from the right side of a. Here observe. Here this is the graph. Here this is some particular point x is equal to a. Here this is y axis. Okay. Here the value of the function from the right side of a. X approaches to a from the right side is called what? Right hand limit. Here this is the value of y. Okay na? Here RHL is equal to limit of f of x as x tends to the right hand limit is a plus limit as h tends to 0, right hand limit f of a plus h. That is what? Right hand limit. Okay. Here observe, if left hand limit is not equal to right hand limit, that is LHL is not equal to RHL, then that function is not continuous. Okay. Here LHL is not equal to RHL, then that function is not continuous. Here next, if the function involves the inequalities, if the function involves the inequalities, then that function, then we have to use left hand limit and right hand limit RHL and right hand limit in order to check whether the function is continuous or not. Okay, on function ನಲ್ಲಿ left hand inequalities ಏನಾದರೂ ಇತ್ತು ಅಂದ್ರೆ ಆ ಫಂಕ್ಷನ್ ಕಂಟಿನ್ಯೂಯಸ್ ಆರ್ ನಾಟ್ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕಂದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಅಂಡ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಕಂಟಿನ್ಯೂಟಿ ನ ಚೆಕ್ ಮಾಡಬೇಕು. ಓಕೆ ರೈಟ್. Okay, in our next class we will discuss some problems on left hand limit and right hand limit and continuity problems. Okay, thank you. Yes, dear students, in this class we will discuss some problems on continuity. Right. Here, in our previous class we discussed about definition of continuity and left hand limit, right hand limit. Okay, here just to recall definition of continuity. Here, a function f of x is said to be continuous at x is equal to a if the following three conditions are satisfied. If that is, first is f of x is defined at x is equal to a, that means f of a exists, and second is limit of f of x as x tends to a exists, that means limit of a function exists at x is equal to a and is what? And is finite. And the third condition is first two conditions are equal, that is limit of f of x as x tends to a is equal to f of x. Okay na? Here we are going to use this definition in order to check whether this function is continuous or not. In order to check whether this function is continuous or not at some particular point here 1 at x is equal to a here is equal to 1. Okay. Here observe, given f of x, given function is what? F of x is equal to 2x plus 3. Here the function f of x is equal to what? 2x plus 3 at x is equal to what? At x is equal to 1. At x is equal to 1. At x is equal to, here in that case x is equal to what? A. Here x is equal to 1. That means a value here is equal to what? 1. Right. Now first condition of continuity is what? First condition of continuity is f of x is defined. F of x is defined as f of a exists. Here also at x is equal to a at x is equal to a. Here a value is equal to what? 1. At x is equal to a is equal to 1. Here f of 1 is equal to, which implies f of 1, f of a exists. F of a exists means f of x plus a, we replace x by 1, that is equal to 2 into x here is 1 plus 3, that is equal to what? 2 into 1 is 2 plus 3 is equal to 5. Okay, here this is first condition, right? Next, second condition, limit of f of x as x tends to a exists and is finite, right? This is equal to limit as x tends to, here a value here is equal to what? A value, a here is equal to 1, x tends to 1, f of x here that is equal to limit as x tends to 1, f of x value here is equal to what? 2x plus 3, 2 into x plus 3. Now as x tends to 1, this becomes 2 into 1 plus 3, 2 into 1 plus 3. If you apply the limit, then this limit get cancelled, that is 2 into 1 plus 3. Then if we apply the limits, then don't write limit as x tends to 1. Okay, right? 2 into 1 plus 3, that is equal to 2 into 1 is 2 plus 3, that is 2 plus 3, that is equal to what? Again, that is 5. Here observe these two conditions. Observe the first two conditions. Here f of 1 is defined, right? Therefore f of 1 is, here which implies f of 1 is defined. And second condition, limit of f of x as x tends to a, limit of f of x as x tends to 1 is exists and that value is equal to 5. Therefore from 1 and 2, we will write this one as limit of f of x as x tends to 1 is equal to what? F of 1. because both are equal to 5. That's equal to 5. Therefore, limit of a function exists at x is equal to a, and that's equal to 5. That means limit of a function exists. Limit of a function exists means what? Function is continuous. Here, first condition is true. Here, limit of f of a is defined. Second condition, limit of f of x as x tends to a is equal to f of a. That's equal to what? Is limit of f of x as x tends to a exists. Second condition is also true. And third condition is what? First two conditions are equal. Here, first condition is 5. Second condition value that's equal to what? 5. That means first two conditions are equal. That means limit of f of x as x tends to 1 is equal to f of 1. That's equal to what? 5. That means what? Therefore, f is continuous, which implies f is continuous at x is equal to which point? At x is equal to 1. Okay, right. Similarly, here, second problem, we have to discuss the continuity of the function or check the continuity of the function at x is equal to continuity of the function f of x is equal to x square at x is equal to some point 0. At x is equal to here, a value is equal to what? 0. Okay, here solution given f of x here is equal to what? X square. Given f of x is equal to x square, at which point? At x is equal to 0. At x is equal to 0. That means a value here is equal to what? 0. Right? Now, here at x, first condition of continuity is what? First condition is f of x exists or f of x is defined. That means f of a exists at x is equal to a value here is what? 0. At x is equal to 0. F of 0, that implies f of 0 is equal to replace x by 0, 0 square is equal to 0. Next, second condition of continuity is what? Limit of a function exists. That means second condition is limit of f of x as x tends to a, right? That's equal to what? Limit as x tends to a value is equal to what? 0. F of x. Here, limit as x tends to 0, f of x value here is what? F of x value here is equal to x square. F of x value here is equal to x square. Now, apply the limit as x tends to 0. Here, 0. X square is 0 square. Okay, that's equal to what? 0. Okay, here this is equation number 1. This is equation number 2. That means case 1 and case 2. Yeah, first two conditions are what? This is also 0, this is also 0. That means limit of f of x as x tends to 0, limit of f of x as x tends to 0 is equal to what? Is equal to f of 0, right? Therefore from 1 and 2, it is clear that limit of f of x as x tends to 0, is equal to f of 0. F of 0 value here is equal to what? 0. Right? Therefore what? Therefore our conclusion is what? Therefore f is continuous. Continuous or not? Continuous. F is continuous at x is equal to which point? At x is equal to 0. At x is equal to 0. Okay. Right. Next. Third problem. Observe. Very important problem. Here observe. Here we have to discuss the continuity of the function. Yes, defined by f of x is equal to 1 if x is less than or equal to 0, and 2 if x is greater than 0 at x is equal to 0. Here observe. How to check continuity for this function? Here observe. In this function involves f of x involves the inequalities x is less than or equal to 0 and greater than 0. Okay, inequalities. If the function involves the inequalities, then we have to use left hand limit. And right hand limit in order to check whether the function is continuous or not. Right? Now, solution. Observe. Here we have to check left hand limit and right hand limit. Okay. Here observe. Solution at x is equal to at x is equal to what? 0. At x is equal to 0, function value is what? At x is equal to 0, function value is 1. That is f of 0 is equal to what? At x is equal to 0 means f of x is equal to what? f of x ಏನಾಗುತ್ತಿಲ್ಲ x is equal to 0 ಆಗ್ತದೆ. f of x is equal to 1 right? At x is equal to 0, f of 0 is equal to 1. Okay, next left hand limit. Left hand limit means what? The value of the function from the left side of a. The value of the function from the left side of a is called left hand limit. Here left side of a means here x is equal to what? X is equal to 0. That means limit of f of x by definition of left hand limit. Limit of f of x as x tends to a minus, right? That's equal to limit of f of x as x tends to a minus. Here that's equal to limit as x tends to a minus means what? Here a value is 0. 0 minus f of x. F of x value is equal to what? F of x here limit as x tends to 0 minus f of x value when 0 minus means less than 0. The value of the function when x is less than 0. 0 minus means less than 0. The value of the function when x is less than 0 is what? 1. Okay, that's equal to limit as x tends to 0, 1. Here, if you apply limit for a constant function, then that becomes a constant one. That becomes constant, same constant. Okay, alright, next. Similarly, right hand limit is equal to RHN is equal to what? Limit of f of x as x tends to a plus, as x tends to a plus. That is equal to limit as x tends to a plus. A value is equal to what? 0 plus. F of x. That is equal to limit as x tends to 0 plus f of x value. Here 0 plus means what? 0 plus means that is the value of the function when x is greater than 0. What is the value of the function when x is greater than 0? That is supposed to, right? The value of the function when x is greater than 0 is 2. If you apply limit for a constant function, then again that becomes a constant, same constant. Okay, right. Here observe, this is equation number 1, this is equation number 2. Here observe, is it these two conditions are equal? Left hand limit is equal to right hand limit. Here observe, here in this case LHL is equal to 1 and RHL is equal to what? 2. Here these two conditions are what? Not equal. Not equal means here this function is not continuous at this particular point x is equal to 0. Okay, therefore f is not continuous at x is equal to 0. X is equal to 0 ನಲ್ಲಿ ಆ ಫಂಕ್ಷನ್ ಆಗಲ್ಲ ಕಂಟಿನ್ಯೂಸ್ ಅಲ್ಲ. Okay, here next here observe we are going to use the definition LHL is equal to limit of f of x as x tends to a minus. We use this definition only because here this function does not have any trigonometric function. Okay, this function does not involve any trigonometric function. That's why we use left hand limit LHL is equal to limit of f of x as x tends to a minus only. If the function involves the trigonometric functions, then we are going to use left hand limit LHL is equal to limit of f of x as x tends to a minus is equal to limit as x tends to 0 f of a minus x. Okay, right. Now one more question here. Discuss the continuity of the function f of x is equal to modulus of x. F of x is equal to modulus of x at x is equal to 0. Observe here modulus function. Here modulus function is defined as modulus of x is equal to, here in our previous class in our first PUC we discussed about the modulus function. Here modulus function is negative x if what? If x is less than 0 and positive x if x is greater than or equal to 0. Right? So here observe this function f pass the inequalities less than and greater than 0, greater than or equal to 0. So we have to use what? Left hand limit and right hand limit in order to check whether this function is continuous or not at this particular point 0. Okay, observe here. First, at x is equal to 0, at x is equal to 0, which implies f of 0 is equal to what? F of 0. F of 0 is at x is equal to 0 means we are going to take this condition. Here the function is this one. Second one is our function at x is equal to 0. Here at x is equal to 0, our function f of x is what? X. That is f of x is equal to x. X value becomes what? 0. At x is equal to 0, f of 0 is equal to 0. Next, left hand limit. For left hand limit, here left hand limit by definition of left hand limit, limit of f of x as x tends to what? A minus. Here a value here is equal to what? A here is equal to x is equal to a is equal to 0 means here a is equal to 0. A is equal to 0 means 0 minus. That is equal to limit as x tends to 0 minus f of x. What is the value of the function when x is less than 0? When x is less than 0, our function becomes what? Minus x. Our function becomes minus x. So if you apply limit for this function, here that is equal to minus 0. Minus 0 is nothing but what? 0. Next, similarly for right hand limit, here limit of f of x as x tends to by right hand limit. Definition of right hand limit is what? Limit of f of x as x tends to a plus. Observe the definition. Right hand limit. Limit of f of x as x tends to a plus. X tends to a plus. A here is equal to what? 0. That means 0 plus x tends to 0 plus. That is equal to limit as x tends to 0 plus. What is the value of the function when x is greater than 0? 0 plus means greater than 0. What is the value of the function when x is greater than 0? When x is greater than 0, our function is positive x. F of x is equal to positive x. If x is greater than 0, that is positive x. Here, now apply the limit as x tends to 0 plus this becomes 0. Right, now observe here, this is equation number 1, this is equation number 2. Okay, here observe these two equations 1 and 2. 1 and 2 are equal. That means LHL is equal to what? RHL. LHL is equal to RHL and that is equal to what? F of 0. That is equal to F of 0. Therefore we conclude that F is continuous. F is continuous at x is equal to which point? At x is equal to 0. Okay, right. Okay, in our next class we will discuss some more problems on